So in this video, we're going to talk about how do I simplify a radical. So let's just talk about really what a radical is. A radical is just undoing a square. So we're going backwards and we're trying to find out like what number did I square to get like the number 25. So let's talk about first of all, our perfect squares. So perfect squares are just a number that have an integer value as its square root. So that means it has like a nice whole number, so like 5, 6 when you go back and take the square root. So we're going to list out our perfect squares. So the way we're going to list out our perfect squares is just by squaring the first 15 numbers. So first, 1 squared is 1. So 1 is the perfect square, and the square root of 1 is actually 1. 2 squared is 4. So if I asked you what the square root of 4 is, it's 2, because that's the number that I squared to get 4. The square root, so if I take 3 squared, I get 9. So 9, if I take the square root of 9, that'd be 3. 4 squared is going to be 16, and let's keep going. So 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. For the most part, we're going to use 12 and on, but these are nice to know. They do eventually come up in geometry. So, okay, these numbers that we just listed here in red, these, I would highlight them. These are my perfect squares. So if I asked you if something is a perfect square, you're going to look back at your list, this list that we made, and see, are any of these numbers come up? So these are perfect squares because when I take the square root of them, you get a nice whole number. So for example, if I ask you what the square root is 144, I actually know what it is. It's a whole number. It's 12. If I asked you what's the square root of 49, you can tell me 7. Now, if I asked you for something like 72, the square root of 72 is not 72 is not on this list, so it is not a whole number. So 72 is not a perfect square. Okay, so that being said, if we have something like 72 or anything like in these examples, they're not perfect squares, so it's not a whole number. If I put the square root of 300 in my calculator, it's going to be a decimal. But the only thing we can do is kind of just simplify it, sort of like with a fraction, we just try to simplify it as much as we can. So if a number is not a perfect square, we try to simplify it by taking out the perfect square multiple. So perfect square multiple. Okay, so for example, the square root of 300. Again, 300 is not a perfect square, but I'm thinking to myself, what number multiplies from this list to give me 300? And the biggest number actually that multiplies is 100. Okay, so what we're going to do is we're going to split this up to the square root of 3 times the square root of 100. So 3 times 100 does give me 300. Now, the perfect square here is not 3. So 3 is going to stay in the perfect, in the square root here, because I don't know what the answer is for that from the top of my head. But I do know that the square root of 100 is 10 from the top of my head. I just kind of would go back in this list. So how did I get 100? I did 10 squared. So that means that the square root of 100 is 10. So we're actually going to make this into a 10. So this is really 10 times the square root of 3. Now this doesn't really look nice. It's kind of like if I had like x times 3, I can rewrite that as 3x. So in this case, what we're going to try to do is do 10 square root 3. We're going to put the 10 or the coefficient in the front. Okay, so now let's try to do the square root of 12. So from my list, I can tell, so first of all, 16 is too big, so we're not going to try that. 9 does not go into 12, but 4 does. I can actually split up 12 into the square root of 4 times the square root of 3. And again, the square root of 3 stays in the perfect square and the square root, because it's not a perfect square. I don't know what the answer to that is. But the square root of 4, I know what the answer to that is. It's 2. So we're going to rewrite this as 2 square root 3. Okay, now this next example right here, I have the square root of 48. There's actually 2 ways to do this. So I'm going to just put a line here to kind of show you both ways. Okay, one way that you can do this is you could have thought of the smaller perfect square, right, first. And you could say, oh, 4 goes into this. So I'm going to split this up into 4 times 12. Good. Great. We're getting there. And so the square root of 4 is 2, and we have 2 square root of 12. Now, this is not completely simplified. If I'm telling you to simplify something, I want it completely simplified. Why is this not? Because the square root of 12, we just learned how to simplify this. So we're going to have to just take one more step and go ahead and redo this. So it's going to, again, this is just 2 times the square root of 4 times the square root of 3. And this is the square root of 4. The square root of 4 is 2, so I can make that into a 2. It comes out of the square root. Now, because it came out of the square root, I can actually multiply this out, and I have here 4 square root 3. Now, if I would have gotten the biggest perfect square that goes into 48, I wouldn't have had to keep doing this twice, but that's okay. It's like when you're simplifying a fraction and you simplify it and then you can keep simplifying. You can do that if you don't think of the biggest number right away. Okay, so actually the biggest perfect square that goes into this is 16, and 16 goes into 48 3 times. So I could have done that in one step, and the square root of 16 is 4. All right, now, if you notice here, once you start getting things out of the square root, you can multiply it with the coefficients because now they're numbers. So here, we already started with a coefficient. So remember, when we start getting things out of the square root, we're going to be able to multiply by that 4. So let's keep that in mind. Here I have 4 times the square root of 32. And I'm thinking to myself, what's the biggest perfect square that can go into that? It's actually also 16. So I can make this into 16 times 2 because that gives me 32. The square root of 16 is actually 4. So now when it comes out of the square root, I'm going to actually write that multiplication sign because the square root, this does mean 4 times the square root of 16, but now that I took out the square root, I need to write that multiplication sign there. And so these are both numbers that I can multiply by itself. I can and get my coefficient. So 4 times 4 is 16, so I get 16 square root of 2. So this is the end of this video, and I hope that you found this useful. We're going to be using this a lot in the next units when we start having functions that have squares in them. We're also going to use this a lot in geometry because a lot of the formulas have a square in them, and so like if we're going backwards and solving for x, we're going to be taking the square root a lot. Okay, so I hope you found this video helpful.